Good morning. I wanted to talk to you all today about fire. I remember I saw my first like procedurally generated fire like in the sometime in the 90s. It was the assembly language program ran really fast on a old 486 computer, but there's like piles of really specific hardware level optimizations. It's I haven't seen the demos much in the last 15 years, but I don't know, it just came to mind one day and I wanted to try to make it. I'm going to walk you through what I did. I found a good algorithm on this website here. Loads computer graphics tutorial. Classic fire effect. It's all in C++. Well, I guess technically C++ is not C syntax specifically. The actual algorithm is not much to it. Generating a color palette right here, trying to capture all the hues from red through orange to yellow. And then we have a loop that goes on forever. On each frame, we're randomizing the colors of the bottom row of the screen. And then we loop over all of the other rows from bottom to top. And we have a averaging function here. Take all the surrounding pixels, plus we're going down 2 on the y-axis, adding those all together, and they get multiplied by this special magic number, 32 over 129. And render all that to the screen, and it looks like you get the picture described here. So, here's what I did. I have a C# project I started using a library. I've been building up this library for months and months and months. Basically provides a really simple way of accessing the pixel buffer with a palette using some OpenGL shaders. It's based on the OpenTK project. But the program that I wrote here, we have some bootstrapping stuff that I'm going to clean up later. It sets up a dependency injection system and loads in the app settings, sets up some command line parameters, and tells it that if when it needs basically for the main state, when the dependency injection container and constructs a main state. Basically, you have to do this if you want the container to be able to instantiate a class. Without that, it will be like, I don't know what that class is. But this allows it to inject any other interfaces it needs. For example, it's like the main state requires a resource manager and a rendering context, and that's injected by the container. You can see here, got that 32 over 129. We have a 2D array for our fire, a palette, and a 256 color palette. Clearing out the fire array, initialize the palette, and this is that's the same math being used in the original demonstration here. The hue is the x value divided by 3. Saturation is kept at max, and then the lightness, got a function here to keep it from going out of range. And the from HSL function, it's a fairly standard function for converting HSL, hue, saturation, and lightness into RGB values. The difference here is that the color set I'm using, you have 6 values of red, 6 values of green, and 6 values of blue. So I am doing base colors. Like there's 2 color objects in this library. One is more of a standard one with 256 values of red, green, and blue. And that has the standard function for converting from the HSL to an RGB value. And then we have this radio color, which can take in the color object and smush it down into the range allowed by the library. I need both because it's like if you're loading from an image, you need to be able to process standard color values. To construct the palette, got some event handlers that we're not using for this demonstration. The render loop, so we're clearing the screen, randomize the bottom row using that same math as the project we're translating. And this is also the same averaging math from the demonstration. I set these in variables because I want to see what happens when we change them. Why is it 32 over, what was the number? 32 over 129. What's so special about those numbers? I want to know. So add those up together, multiply by this factor to kind of average them, and then we render it all to the screen, 1 pixel at a time. It runs pretty fast because if you check in the app settings, it's like while the window is 1280 by 720, the actual virtual display is only 320 by 240. There's no updating. There's key down and key up event handlers. Basically, if you use the arrow keys, you can adjust the factor 0 and factor 1 just so we can see what happens. And let's run that and see what it does. So there you go. We have our fire demo smushed down into our radial palette object. It's kind of neat. I'd like to be able to do a couple more things. So one thing I'd really love to be able to do, I want to be able to write some words to the screen and then watch them catch fire. I think that would be a neat effect. So let's try a couple things. One thing, if you want to be able to write to the screen, being able to draw flames on the screen is a good intermediary step. On the second branch here, feature branch, let's walk through what's changed. Oh, millisecond per flame update. I'll explain that in just a minute. Basically slowing down the fire. Got the size of the pen we're going to draw with, and we have to set up an update timer. Constructor has not changed. Nothing in the load and unload. Rendering has changed a little bit because all this is doing is setting the pixels to the screen. Actually calculating the color of those pixels has moved over to the update, which has a lot more going on. These calculations are exactly the same as far as averaging things together to calculate the color of the fire. Still randomizing the bottom row the same way. The things that's changed is this, setting an ember on the screen to the size of the pen, and using this update timer to slow things down. We can use the mouse wheel to control the size of the pen, and we're tracking the mouse position and whether or not the mouse was pressed or released. That set ember function we just saw, you feed it a size, and then it's going to render a randomized color circle wherever you click the mouse. That's what we have going on here. Iterating over the size of the pen. Like the size is the radius of the pen. And then this math makes sure that you are inside of a circle before you render, write a color to the fire buffer. I'm going to start by disabling the timer so that you can see why we have a timer. full-size flame. I try drawing, and basically it's like we're holding up a match. It's moving so quickly that it just kind of disappears immediately, which isn't very much fun for writing. So my solution in this iteration was to slow down the flame update. Not quite as nice on the eyes. I don't know, it's kind of neat watching the colors slowly change. But you can do this. And that's fun. Let's try changing the size of the pen. Not really liking the appearance of the random color blob, but it is making some neat patterns, and it lets you draw. Like, you can actually see what it's doing. Whatever you draw just kind of like floats up to the top of the screen and disappears. And it's fun. It's satisfying to draw with. And I love watching the colors merge and fade. I do not like that we had to slow down the simulation so much. I want to be able to draw at full speed and still be able to see what I'm drawing. Now, the idea I had for this was, instead of writing directly to the flame buffer, we can have the mouse draw particle emitters to the screen. So you can kind of picture that instead of placing the flames directly, we're placing something there that will emit flames for some amount of time with some set of parameters. So let's switch over to the next branch. Let's see, we don't need those changes. That's weird. I must have... That was a mistake. Gotta watch out for those. The next feature branch is particles. And let's see, reviewing what all changed here. We have multiple classes going on. I moved, like, instead of the two-dimensional array for our fire, I moved it into this fire buffer class. The reason I did that is it makes it a little bit easier to take the whole fire buffer and pass it off to another class. Like if you want your particle fountain to be able to work with it, or your particle class, just passing the whole fire buffer back and forth. Initialization hasn't changed too much. I did not show you all what modifying factor 0 and 1 do. We'll get to that in just a moment. Rendering is basically the same, writing the whole fire buffer to the screen. Data is the reference to our fire buffer now. Updating has changed a little bit. See, it's not writing the embers anymore. Not here anyway. We're randomizing the bottom row and doing our fire calculations. Setting the ember has not changed. Ha! I was just walking you through the fire buffer class, not the main state. All that was to initialize the main state. The initialize the fire buffer. The fire is able to update itself and render itself. And in the main state class, it's like we have the fire buffer, we have a particle fountain, a single particle fountain with a set spawn rate 100 milliseconds. Then render here has actually changed a lot because rendering the fire buffer has been offloaded to the fire class. First, we tell the fountain to render any particles it wants to the fire buffer. Okay. The fountains update, the fire updates. The pen controls are basically the same as they were. And it's like if you press down on the mouse button will activate the fountain, release the mouse button to deactivate the fountain. In the particle fountain itself, I've taken to using these basically props classes, or structs records. I picked this up while doing AWS projects. It's I like doing this with constructors because it makes it really easy to add or remove properties. And it's like if you wanted to serialize the particle fountain, you basically just need to be able to serialize the props struct. It makes it a little bit more straightforward. So the particle fountain has a position which is going to be relocated to wherever the mouse is. Is it active? Like receiving active when it's receiving events. You can turn it on and off whether it's visible. And I left some notes here. Yeah, particles need to be spawned right away when the fountain is moved, otherwise several moves might happen before the next spawning, which leads to weird jumpy visual effects. That was a kind of a fun bug. So whenever you move the particle fountain, you need to immediately push something there, or like create a particle there. That way it looks like something is happening when you move the mouse around. Only spawn particles when it's active, but you need to keep updating any existing particles on the screen, because just because you release the mouse, like, you don't want to stop moving the other particles on the screen. All right. And yeah, the particle itself needs to be a class. I ran into this fun bug where I originally had particle described as a struct, and then in the update loop moved all the particles. I was doing all the math right, but when I ran the program, nothing was changing. Particles just kind of sat there. Problem is, because a struct is not a reference type, every time you access, like, if you... Here, I'll show you. Particle fountain, going to update. If I grabbed a particle off of the array and change its position, I'd actually be changing a copy of that particle. I wouldn't be changing the original reference, basically. I think I was actually like doing something like this. Like, that makes a copy of a struct. And then if you like change its position, you're not changing the position of the particle in the array, you're changing the position of P. Also, if you try removing particles, it's like this particle here is part of the for each loop. That's not the original particle. And it's going to search this whole array for a reference to that particle and won't be able to find it, because things without reference types work. Okay, so if you run this, the fire is running at full speed, and you got that weird visual artifact. Ignore that for the moment. But now we are drawing particle fountains. So we can run the whole thing at full speed, and we can also draw. Wait for that to fade for just a moment. Still got a couple of bugs related to when we move the mouse cursor around. But it's working pretty well. It's fun. Also, it's like if you change that scaling factor with the arrow keys, it's like right now left and right seems to be changing the height of the fire pretty drastically. And the up and down takes a little bit more to get the fire to move, but it's kind of neat to know that we can do that, scale the fire up and down. Okay, so moving on. We still can't set letters on fire, not easily. I mean, go back to our project here. I mean, you can actually like do this, write some letters, watch them burn. It's not exactly what I'm going for, though. Alright, brush management. Next feature branch. Why is there an error there? Let's try, make sure we reset everything. Okay. No? Did I commit a broken branch? No, I think Visual Studio VS Code is getting confused because I keep changing the project. See if I can tell it to restart. Yeah. Close, reopen. Okay. So next branch, we're working on brushes. I don't like that weird looks like a random noise that we're drawing with. I want to be able to draw with other shapes. This branch introduces the concept of a brush. An interface, find the brush. We have our existing brush, just kind of a noisy circle. Over the size of the brush, we are drawing random pixels. And I also introduced this blobby circle fire brush. Still going over the area of the circle, but for this one, we're introducing basically the ability to have the brush flicker. Like it's going to get bigger and smaller, and also to blend with its background. Whatever was already, it's going to take whatever is currently at that location in the fire buffer into account when it writes the new color, which should just make it look nice. Over in the main state itself, the fire buffer itself has changed some. Replace those two, like the factor 0 and factor 1, with a single smoothing scale. It's like it's always dividing those two numbers, so we can just store that value and modify that instead. And then instead of modifying one or the other number, we're just going to bump the scale up and down. The breadth and depth, I was playing with the averaging function itself, but I don't know. It was interesting. I'll show you in just a minute, but it doesn't have quite the same. It's not as useful as I thought it would be. And same palette size. See, we're changing the math a little bit, taking the breadth and depth of the averaging area into account while it's doing its averaging. And this thing right here replaced the, I think that all the math of should it update? Is it time to update? I kind of just wrote a little timer here. Event trigger. Give it a time span, and it'll just keep updating itself. It'll let you know when it's time for the event to happen, and then you can tell it to reset. Just one. I don't know. It's not quite as necessary, but I was bored and wrote it anyway. So the main thing here, A and D modify the smoothing scale, and then you can play with the averaging function with the arrow keys. Let's see what our new brush effect does to the display. So, A and D adjust the smoothing scale. You have to push it a bunch more times. It goes up slowly, goes back down slowly. But I feel like it's a lot easier to adjust the intensity of the flame now. That's fun. Let's put the flame down low. And the arrow keys are adjusting the averaging area, which adjusting that isn't quite as useful. It's like you can push the down arrow, it goes all white, and I think if you adjust the smoothing scale enough that you'll get some different effects. I was able to get it to do a kind of interesting banding effect last time I tried this, but I don't quite have the patience for toggling the parameters right now. And there's our new brush. You can see as we draw that it kind of blends nicely. There's some flicker going on. I like the way it looks. Still can't. I want to be able to write to the screen with a sprite font and set the letters on fire. That is the end goal of all of this project. Okay, so the next feature branch here is that goal. So the thing that's going on here, not that project, this one. The way I finally got this to work. Okay. Offloaded the palette into its own class. Allows us to change the size a little bit easier. Let's go over to our main state. Now it's fussy again about me changing the project. Hold on. Reload. Okay. So now, instead of a single, let's see, we have a single drawing fountain. We also, where is it? So we're loading in a tile set. Getting a set of tiles, like, basically I have classes already defined that will load in an image, convert it to a bitmap, and then carve that up into an array of tiles. And we have this consumables thing going on. What we are doing here, I'm going to give more of a high-level overview. The code's all going to be on GitHub if you want to take a look at it. Particle fountain factory. We have one kind of particle fountain for drawing, and a different kind for burning tiles. If you're burning a letter, it's going to spawn particles a lot faster compared to drawing. And the lifespan is the same. Scale is a little bit smaller. And the brush that the tile burner is going to be working with is basically the same. Noise is basically the same. The noise is basically a value used to adjust any of the other parameters that the particle fountain uses, that along with a random function to be able to basically adjust the parameters back and forth. But we have a consumable tile set, which is composed of consumable tiles. Let's see, best way to describe this. A consumable tile renders to the screen just like a regular tile. The difference is that it has a timer for how it's being consumed. A lot of these could have been moved to one of those configurable props classes. I just haven't done it yet. It's going to wait 1,000 milliseconds before it starts burning. And it's going to burn each row at 500 milliseconds, a half second per row. And there's a noise factor means the letters won't all burn regularly at the same rate. Consumption delay. Basically, we're counting down a consumption timer, but some frames count more than others. That's what the noise factor is doing here. We wait until the consumption timer is triggered, and if the letter has been completely consumed, then we don't have anything else to update. We also have a delay before the tile is rendered at all. It allows letters to look like you write a whole string of text to the screen, and that render delay allows the letters to appear one at a time as if they're being typed. And then we have a consumption timer here that every time that's triggered, we update the offsets so that it's kind of eating down the rows of the tile. And then we are telling it, the particle fountain, to write a bunch of particles along that row, along the entire width of the current consumption row. If that tile is active, because we don't want to make it bitmap tiles are black and white. We're burning the white tiles, we're leaving the black tiles alone because there's nothing there. And then for the normal tile render, we are only rendering the rows that are past, if it's been consumed, don't render it. That's what this thing's doing. And for the tile set itself, it's we feed it that bitmap the set of tiles that I showed you from the main state. We feed that in the render function. It doesn't. The consumable tile set doesn't actually have to know what the actual images it's working with in the constructor. It doesn't have to know that until the render and update functions. When you're writing a string, it just adds a whole set of consumable tiles to the array of tiles that it's tracking. And then each tile that it writes knows its pixel position and what color it should be, and various other parameters there. So, if all this works, which I've tested before, I know it works, I'm going to hit the space bar. It's going to write some text to the screen. And there it goes. I really like how it looks like it's the flames are kind of dribbling down past the letters as it's being consumed. Hit the spacebar multiple times, it'll just keep writing the same words and then triggering more fire effect. So it's really satisfying to watch. The last feature branch here was just about performance. It's something that reload. It's something I've been doing a lot of with some of the projects lately. Back in the fire buffer. Why use a for each loop when you have a parallel for loop? Or parallel for each loop? Write all the pixels simultaneously. There's really no reason not to. I could use a shader. Probably be even more performant, but this is performant enough. Yeah, I have some notes around the code about why I did various things if you want to read that more. And yeah, since we're able to do this because it's like nothing else is writing to the buffer when we're doing the update. We'll probably do the parallel for each here also, because the render function is the only thing rendering when we get to this step. Let's see, were there any other notes on performance here? Notes on the banding effect. Like if you wanted to play around with that and see what happens. I made a change here. It was like instead of having a big switch case block, I added a extension method to the key to allow me to create an axis out of two keys. Can't tell if it's better or not. I guess it's a little easier to tell what's going on. But that is basically it. The entire adventure of creating fire and finding creative ways of setting things on fire. So, thank you for joining me on this adventure. See you around.